Alright, Webster Groves, welcome back. Hickson Middle School. This is Electrical Energy, Goal 1. In order to meet the goal, students will be able to describe the interactions of like and unlike charges. Alright, here we go. So I kind of picked the scariest pictures I could. Wow, I mean, how old is this person now? And do they regret taking this photo? If I ever wear a sweater that is buttoned down with reindeer on it, please let me know. Showing signs of receding hairlines here, but this guy is oblivious to what's going on, and this person is just having a bad hair day, so please don't get in our way. Let's talk about static electricity. Static electricity is a stationary electric charge. We know that because of the word static in there that tells us that it's not going anywhere. It's stationary. So a bit of a review. We're going to need to know the parts of an atom here because that has to do with electricity. However, electricity is not made of matter because it does not have a volume. It does not have a mass. So it's not made of matter. What are the charged parts of an atom? Charged parts are the protons. Negative parts are electrons, and the neutral parts are the neutrons here. So positive protons, negative electrons, neutral neutrons. Okay? So this is a neutral atom because it has the same number of protons as it does electrons. Okay, so that's parts of an atom. Know that electron, negative, proton, positive. Okay, you're going to need to know that. So in the world of charges, opposites attract. In the dating world, I don't think so. But here, with charges, opposites attract. Like charges repel each other. So if you're going to have two negative charges, they're going to repel, or two positives, they're going to repel. It's nearly impossible to know if something is a negative or a positive charge. You can know that you have two different charges, or you can know that you have two of the same charge, but as to know like which one is negative or which one's positive, unless it's like a magnet, you're not gonna, or a battery, you're not gonna know. So here with the magnets we have like charges because all three of them are repelling each other. Okay, so that's why it looks like they're floating, but we just have magnetic forces here that are repelling each other, that are pushing away. Okay, because they're the same charge. They're like charges and they repel each other. Okay, here this kind of explains how we get a charge. If you lose electrons, that means you have more protons, so it's positive charge. If you gain electrons, that means you have a negative charge because you have more negative particles. Okay, a neutral atom is going to have the same number of protons and electrons. So next, charges can be transferred. Yes, they can be. There are three ways. One way is friction. This is like combing your hair. Okay, combing your hair, the brush is rubbing up against your hair, and so either the hair or the brush is gaining electrons, becoming negative, and that is one way that charges can be transferred. So something that gains electrons becomes negative, something that loses electrons becomes positive. An example of that, we said comb through the hair, or feet, rubbing against the carpet. Same kind of thing, friction. Conduction. This is transferred of electrons by direct contact. An example would be the static electricity built up in your sock transferring to your foot. The sock is touching the foot, so there's a direct conduction there happening of the charge. Induction is a transfer of electrons due to an electric field. Getting your hand close to an object, like getting your hand close to a doorknob and getting shocked. Okay, that would be induction. Or lightning, that would be induction. same kind of thing happening. Okay. Neutral, neutral means no charge. Same number of protons and electrons. Negative charge, you're gaining electrons. Positive charge, you're losing electrons. Okay, so that is a neutral charge. How is this different than a magnet? Well, magnets are always going to have a positive and a negative. Okay, where there's going to be a north, there's going to be a south when it comes to magnets. Charges are different. You can have just a positive charge, or you can have just a negative charge. It's going to exist by itself, all on its own. Example of static electricity discharge: getting shocked, a spark, or lightning. Okay, here's one lightning strike that ends up being pretty close to these people. Okay, so this is the same thing that happens when we get shocked. Okay, but I mean, not nearly as powerful. So this is induction. That's how the electrons are being transferred here, induction. Okay. So that air heats up and we're able to see the light. This is the same thing that's happening when we get shocked. Like if we build up friction, okay, and we put our hand close to a doorknob, the transfer of electrons happens. So we have friction, and we have conduction, and we have induction. Okay, getting close to an electric field. Okay, so lightning and getting shocked, that's kind of the same thing. Okay, induction is happening. Transfer of electric fields, transfer of electrons. Okay, so how does lightning occur? Well, the same kind of thing, in the same way that we are like rubbing our foot against the carpet, the air is swirling up in the atmosphere, causing friction. There's a buildup of charges or electrons, and then in order to restore it to a neutral condition, those electrons must be transferred. Those electrons are transferred to the ground or wherever it strikes, and then that transfer of electrons causes the air to heat up, which causes the lightning that we see. Okay, so same thing, that induction process is still happening. Okay, buildup of friction, and then those electrons pass through the air when the electric fields get close to each other. So that's it and that's all. Please bring your questions to class. If you are not sure about anything that is in your notes, let me know. Later.